they're actually different size books on the top of it, and it seems, maintains its balance. And he did this one. It could either use a Nucleo board or yeah.
That's a ESP32 board.
Yeah, I think it's it may be similar to that new Arduino board with an ESP32 on it. I forget what it's called.
Mm-hmm.
I think that's one of the smaller Nucleo boards, the cheaper one.
Well, the Nucleo board is off to the left up there. This is a different board.
Yeah, that's what I was. That's what I meant. That white Nucleo board isn't the big one, I don't think.
Anyway, it works with either board.
Some of those brushless motors have more torque, just how they're designed, than others. So you want to get the right brushless motor for that sort of application.
Who was it? John last week that was doing brushless?
Yeah, Waylon.
Yeah.
Yep.
I think David Anderson did a balancing bot on.
Right, that's what I was trying to think of. This, I would say, is on the order of what he did.
I like how rigid that bottom is.
Looks
How it's all
pretty
just
big,
one
yeah.
3D printed part. That's pretty cool.
Yeah, it looks like there's some nice encoders on that.
Yeah.
Although I think those FOC controllers can tell you where the wheels are, right? Without encoders.
I think you're right, but I think the encoders, it's just easier to use encoders, I think.
Yeah, it'd probably give you more precision or something.
Yeah.
Those are called FOC.
Yep.
Correct.
Okay. Now, Ray, did you? This is a video of somebody else, right? You didn't build this, right?
Oh, no.
No.
Nope. Somebody else's video.
Yeah. Did you put the link in?
Not yet, no.
Okay.
But kind of the things he does, it's like they're like impulse loads on it by, actually like placing or almost tossing a book on it.
Since does it recover if it falls? Is that what the purpose of the special shaped tray on the top?
No, I think it's to carry stuff or to put stuff on. So to show that it can still balance it even though it's like off center.
Yeah.
Or a heavy weight.
Mm-hmm.
Maybe you can hold a beer can.
It might
about right.
he puts a pretty good sized book on it.
So someone, I think it was last week, was saying that the FOC controllers work a little like stepper motor drivers. Right?
Yeah, they do. I think some of them sense current out of 2 of the 3 phases,
Yeah.
and I think that's how you get that information from that. But I'm just starting to get into it, so probably
Okay.
John will be the better. Well, I don't know if John's here tonight, but he's probably the better.
Yeah, I think one fundamental difference is most stepper motors, not all, but most stepper motors are only 2 phases, where these
Right.
are almost always 3 phases. And so that makes it a little different.
Yeah, so it's got a Bluetooth app that you can
And
use.
I think, aren't these guys essentially, compared to a stepper, they're inside out? Otherwise, on a stepper motor, I think the stator is on the outside, and on these guys, I think what we would normally consider the rotor is on the outside, or at least on some of them. And that's, I
I think that
believe,
needs.
it gives you more torque, and I think it also helps you save weight.
Yeah, I think that interface he's using is the cloud IoT stuff from Arduino Cloud.
Yeah, so there's.
Oh, that's cool.
That is cool. Wait a minute, well, I can see his finger. I guess
Well,
he's
kind of poking
disturbing.
it.
Yeah.
Still balance.
Mhm.
Yeah, they seem to run a lot smoother than stepper motors also.
Yeah. Yes, these, if you, another name for this type of motor is synchronous motor, and, yes, you're right. They run, there's no steps in them. There's not, like you see in a stepper motor, you have steps and whatnot, but these just run continuously. Wonder how many times he had to do that.
I don't know. I'm not seeing any cuts or jumps in the video.
He's not showing us the fails though. At least not yet.
Not yet.
On my first robot, I tried to use steppers as the main drive, and I had trouble. The ones I was using anyway didn't really have enough torque to drive. I mean, granted, that was an unbelievably heavy robot, overweight.
Yeah.
But I had, relative to the kind of power I could get from a brushed DC motor, the steppers never had that kind of torque that I tried.
Right. Well, seems pretty robust.
Yep.
Yeah.
He does the thing where he.
Oh, so now he's just going to use the ES.
Nucleo.
Yeah.
I like that he showed the offset loads.
Yeah.
A problem that I had early on in conceptualization was thinking that these things were actually trying to find the balance point. And they're not. They're trying to find the place of least rotation. Right? And so yeah.
Yeah, I guess there is a difference.
Yep. The least point of least rotation is the balance point for any dynamic system, basically.
Does he have it driving anywhere, or does he have that control yet? Like David, he can make his go anywhere. He can go waypoints with his.
He was showing it driving around earlier.
Oh yeah.
Yeah, but he was doing
Yeah. With a controller on his phone. Yeah.
So I don't.
It wasn't autonomous navigation. That's a different topic.
Yeah.
Yeah. Yeah. So he's putting pretty good, offsets, heavy books on it. It still seems to maintain.
Did anybody, did he stand it up when he started it, or did it recover from the ground? I know some use like little lever arms that'll pop out and cause it to jump up.
He hasn't shown it recover yet
Yeah.
or stand
Yeah.
up.
Yeah, he put it on the start of the video. He puts it down standing, so it doesn't start from laying down. He
Okay.
Yeah, he does hold it up. It's like the IMU looks like the IMU needs to calibrate, and I think there's different. Yeah.
I don't know how you code for that.
Yeah.
Oh, this, yeah.
So there's a challenge there. You can make a 6-can robot out of a balancing
Oh,
robot.
that'd be cool. I'd love to see that.
Anyway, I don't know how much force it takes to shut the door, but it's not bad.
Nope, not bad at all.
Think you could push a can with that much force?
Oh yeah, if he could move that ball, I think he could. Now the problem would be, I don't know how picking up a can might cause some issues.
Controlling it might be difficult.
Yeah.
Yeah. Anyway, I've gotten last night I ordered 2 of the same little gimbal motors and a controller, but looks like it may be here in the middle of March.
Oh, wow. Does this look like a future project, Ray?
No, I wanted to use it for a 6-can robot.
Okay.
Cool.
Yeah.
Yeah.
Bill?
Not balancing.
No, but I thought that seemed to balance really well, and it seems like
Yeah.
Harold's had some kind of a tough time getting his balancing robots working, and it looked like he was looking for new and different code for the 6050 IMU, and so that used the 6050,
cool.
and it seemed to do a pretty good job of balancing. So,
Seen a lot of people start to use cycloid gearboxes with BLDC.
mm-hmm.
Has anybody done that in the group?
Mm-mm.
Or what is the other one? The wave?
Harmonic drive.
Yeah, harmonic drive.
Yeah. Nope.
That'd be interesting.
Yeah, I had the opportunity to get some when I worked for TI. A guy was coming in. He was looking for somebody just to give these things to. But at the time, I thought, I don't really have any application for those, and didn't bother following up with them. So, but could have gotten 2 nice.
I've seen a lot of 3D print projects trying to do that, and some of them seem to stand up. I don't know how well they'd age, but they seem to stand up pretty well. For the limited testing I've seen, even 3D printed some of them. So, especially for the harmonic wave ones, you need to have flexibility in the housing in order
Yep.
to pull that off.
I kind of went down that rabbit hole, and I think it's great for YouTube videos. I don't know that it's really the right approach to take, except for very special use cases.
That was my fear. Thank you.
Yeah. If you have, if you're space constrained and you need something in a super tight package, but yeah, they're not cheap either. I mean, you can look on eBay and, they're pretty expensive. But this was an all metal one. It actually, there was like what they call the wave generator, which is like, like a piece that was connected to the center shaft with, like 2 lobes on it, and it had 2 bearings, and that deformed a gear with very small teeth, enough so it contacted an outer ring. So you had the wave spinning and making contact with that outer ring, and you can get really high reduction ratios out of it too. I think 60 to 1, 100 to 1, and the wave moves like whoops. Okay, yeah, we'll do that. The wave moves one revolution, and that moves that inner ring like one tooth, and typically, and that's how you get such high reduction ratios. So the outer ring and the inner ring are different by just one tooth. And
hey, Doug, I think I have that link if you want me to go ahead and post.
Well, Ray, either one.
Oh,
I don't care. I would like to see it posted, though.
Yeah.
And hey, we are recording, by the way. So anybody got you want to form a queue here so we can move on from this presentation? Anybody who's got anything? Who wants to?
I have a show and tell and a presentation.
Okay, Mike's got one. Anybody else? Oh, I see Pat. Okay. Anybody else? I don't see any more eyes. Oh, okay. We'll start off with Mike and Pat, and then we'll go to. Oh, did I see a Ted raise his hand? Or was that you scratching
I
your
was
goat?
scratching my ear.
Okay, all right.
Sold.
Okay. All right. So, Ray, you going? Anything else?
I think that's the link. It seems awfully long. YouTube video, simple. Yeah, I don't think you need all of that. Yeah. Okay, just the end part of it, I think.
Yeah, that link does work.
Oh, it does? Okay.
Yeah.
Okay. We'll leave it there. Well, if it works, that's like, wow, that's good. Okay.
Anyhow.
Okay. Well, that was interesting. So I'll be intrigued to see how how you use your motors, and I guess there's no gearbox on them, so they don't have the gear lash.
Yep.
Sounds like it has a lot of, and I believe the controllers are smaller too, aren't they typically? Well, I guess you can get small motor controllers now.
Yeah. Yep. They're pretty small.
And lightweight.
Not very expensive.
What's the shaft thickness, or shaft diameter, I should say?
On those, I don't know. Don't think I saw any.
I mean, they don't have like real tiny shafts that you got to build up or anything, do they?
I didn't think so. It seemed pretty good size. If I had to guess, maybe 8 millimeters.
8 mil? Oh, that's pretty. That's huge.
Yeah.
That's like 3/8 of an inch or something.
It's hollow though, so I think.
Okay.
There was very little information on the. It's like the guy said, "Here's the part number for the motor," and it's like, okay.
Okay.
So.
I didn't go to the link. What does it cost?
I think 2 of the motors were like less than 17 each, and that included what is it? The AS 5400, the magnetic encoder. That's let's see, what would you say? I've got some here.
So it's a wheel and encoder.
Yeah, wheel and encoder for less than 17.
That's reasonable.
Yeah, the AS 5600 is built into that motor.
Okay.
So I don't know. They look kind of neat. I mean, it's kind of like, I've got an old Black & Decker DC motor drill, and my wife bought a she actually wanted the battery for a weed whacker, and with the battery, you got a free drill, if you can believe that. So, you know, and this thing is it's a 3-phase brushless motor, and it, you know, it blows away the other, big, heavy Black & Decker thing. It's, it's more powerful. It spins much faster. The drill weighs less. So,
Sounds good.
Yeah.
Okay, let's give it to Mike. Mike, you ready to do your presentation or whatever?
Yeah. So I was working on my my blob detection for the can and the measurement of the distance. And I came up with a way to do the distance only with the blob detection.
Mm-hmm.
So let me show that.
So you did like a pixel count, X, Y, and
No.
yeah.
Say, trying to figure out how to. Oh, here we go.
Simple trigonometry.
Okay, so let me bring that up. Where is that? Oh, there it is. Okay, so can you see the title screen?
Yep.
Mm-hmm.
Okay, so basically it's just using the blob detection for location measurement with just simple trigonometry.
Okay.
And so basically what it does is it's depending on the blob to be placed in the center of the can. So it's basically uses the fact that this distance here, which is the distance from the camera pointing straight out and the middle of the can, and it's 90 millimeters. So I can find the distance in the forward or X direction using basically the 90 millimeters would be, this is the angle, and this is what I know, and I got to figure out what that is, the B. So I know what the opposite A is, and I'm just looking for what the adjacent one is. And so the thing is, like, how do you determine the angle here? So the angle is the vertical field of view, and which is radians or typically degrees. In this particular example, I'm using a 50 degree. I think my camera has a 55, but I just rounded up a number. And so the distance would be 90 millimeters divided by the tangent of theta, because over here tangent of theta is equal to A over B. So you just do the little math, and that'll give you the distance to the can in the forward direction. And so I was doing the math on here, and so that's sort of what you would come up with. And then once you know the distance, then you can figure out where it is on the y-axis, like left and right, because you know what the distance is. You're looking for the distance y. And so this is the top view of the camera, and its field of view is, say, 70 degrees. And again, I can get the angle, the theta, by the horizontal field of view times the blob x measurement, which is the offset, in the left and right direction, divided by the SVGA x width. Like I'm using SVGA in my camera, and it's 800 pixels wide. So that gives me the blob x over the over that gives me the amount of area on, I mean, the distance in terms of pixels, which you can use to figure out what it is, and use the horizontal field of view to figure out what the theta is. And then again, the distance is equal, y is equal to the distance of x. So you know this distance, you're looking for this distance. So now you know b, basically, and you're looking for a. And so you do distance x times tangent of theta. So it works pretty good. But the one thing, like the XY coordinates relative to the robot are pretty accurate and reliable. The blob detection, of course, needs lots of help to detect only cans. So I've been tinkering with that. And the interesting thing is when this can moves forward, once you can't see the whole can, then the middle of the can isn't the middle of the blob measurement isn't the middle of the can, it's a partial of the can. So it's, so you don't know the 90 anymore. So on my measurement, I can only go to like 300 millimeters before I don't see the whole can from my camera. And so if the can moves further than this point, then you have to stop using it and then come up with a different way. But once it's that close, you can use a simpler time of flight, just a direct point beam to pull it in the rest of the way. But one thing that I don't understand is the square root of 2. Because when I just look at the math and the algebra and the trigonometry, it looks like I don't need the square root of 2 on the tangent to make this thing work. But through trial and error, I determined that I needed the square root of 2 to make it actually be accurate over all the distances. So I've been Googling on it saying, why would I want to use the square root of 2 with the tangent? And I can't figure it out. So that's the my little presentation here is this does work, and you can probably use a much less expensive camera than my OpenMV, and you could probably use the OpenCV free software and get the blob measurement and be able to do the distance measurement. Of course, it only works when you're looking for a specific thing like the can. And so I was going to change. Let's see. I'm going to stop presenting this, and I'll present something else. Okay, so this is my. Oh, I need to turn this on. Okay, so you can see the floor, and so am I still here with y'all?
I don't know. We're not. All we're seeing is an RWiz window.
Okay, there's an RViz window, but my second window, I have a second window.
You might have to change.
There's another camera.
Yeah.
You have another camera, but it's on a separate feed.
It disappears if you don't have audio on it for some of us.
Oh. Okay.
And then you've got a feedback loop.
Huh.
Put the audio on the wide shot and not on your close shot.
Huh?
Not on your headshot.
Oh, the RViz is my presentation, so so let me take the audio off of that.
It doesn't matter about the audio on the RViz. That's just your presentation. But
Right, so I'll
take the audio off your headshot of your face camera, and then move it to the wide camera.
The one that's on showing the
The
floor.
one showing the floor. Yeah.
Yeah. So how's that?
I don't think it worked.
Oh!
You can only have one microphone, one speaker.
Okay, try it again, Mike. I muted your speaker. Let's see if that does anything. We'll see. Probably won't.
So how do I turn this audio on? Oh, okay. So I switched audio, mic and speaker to the camera on the floor. Is it working okay now?
Yep.
Yeah.
Okay. Thanks for the information. One of those things. Okay. So you notice that the floor is sort of marked out like my RViz, my map, and I got the can. On RViz, I got the can over here, and I'm not going to use these waypoints. And it's going to be in a different mode where I use the can for a sort of a waypoint instead of this. So I'm going to, what's going on here? So I'm going to turn this thing on. So right now you can see the, this thing is pointing this way instead of at the can, so it can't see the can. So I'm going to do I'm going to push this button, it'll go into a mode where it says, find the can and go to it. So you can see and then it stopped right before the can went off the screen. So it's that's sort of my.
Oops.
You dropped off, Mike. We lost you. Oh, you. I don't know. I don't see him moving. I think he may have just completely fallen off the screen.
Froze.
Yeah, looks like he's frozen.
Yeah.
Hey, Mike, if you can hear us. Oh, okay, he's left.
So I didn't quite catch all of his equations, but his issue with the square root of 2, if the diagonal of a square is the square root of 2 of the times the side. So I think he's got the diagonal mixed up with the length there somewhere.
Yeah. You back, Mike? I don't think so. I don't see him.
Yeah, actually in that you can use, like if part of his can gets cut off, he can use the horizontal width of the blob that's, that's proportional to distance too. So even though maybe the bottom of the can gets cut off, so you can't use the Y, but you could use the width of the X of the blob to.
The width is much less reliable, though, right? Because of the way that you get specular reflections. And it's quite often, especially with color blobs, you might lose the edges of the width, whereas the height of a cylinder is usually a pretty good fiduciary for the distance.
I noticed that. Yeah. sometimes it only sees half of it depending on the shading of the light.
Yeah.
Oh, so Mike, I was thinking that if you take a square, the diagonal is the square root of 2 times the length of the side. So I think you might have the hypotenuse of the triangle mixed up with the length of the bottom base or something. I didn't quite catch your equations there, but something like that.
Oh, yeah. Let me pull them back up. It's relatively easy to do.
So you might want to try using the sine instead of the tangent.
See, oh, here it is.
So, okay, so you're trying to calculate distance x or the hypotenuse distance.
Right now, I know the opposite distance, A, and I need to know the distance to the
Okay.
plane here.
Yeah,
is-
so
I'm not looking for the distance to the camera. I'm just looking for the where the x parameter is on the field on the map.
yeah, so tangent is the correct formula for that.
Right.
Yes, I don't know why you'd have a square root of 2 in there.
I don't know. It's bugging me, but
Yeah.
it works, but it bugs me. Yeah. Yeah, so I'm pretty excited about it, but knowing what I know now, I probably should have got a Oak D camera. Because it's a little fiddly.
Cool.
All right, so I'm going to stop sharing this. All right,
Okay.
so that's my show and tell for now.
Okay. Hey, Pat, you ready?
Yep, I'm ready to go. Okay.
Might have been an earthquake in Canada.
Little stuff to see. How about that?
Yep.
All right.
Better. Been working, troubleshooting and staying up all night and troubleshooting, trying to get this thing to go. And
Is it?
It's going.
it's going.
Yeah.
So I have both motors going with the PID loop. I still got some tuning to do in the PID loop. On the screen, I'll just share my screen in a second. I've got data coming back. Everything is working right now the way it should, which is a long, hard struggle. But what I want to show, as well as that, I'm going to stop that. I'm going to share my screen. Share. Okay, everybody see that?
Mm-hmm.
And it says I got an infinity mirror.
Mm-hmm.
Are you seeing an infinity mirror?
Nope. I'm not.
Nope.
Oh, no.
Okay. Okay, because it shouldn't be. I'm sharing the laptop of my laptop that's talking to my Pi.
Okay.
So my laptop's in the other room. I'm using my work computer. So I've been working on this program. This is the one that's loaded in there right now. So when I run it, and I'm going to reset this, otherwise, well, I can just run it anyway. I've got a wind-up issue with my PID loop. It's going to go crazy for a second. And so I've got to get that fixed. Then it settles back in and starts running. So you can see I don't know if you can see my cursor.
Yes.
The number to the right is my set point at 20 centimeters per second. The next number to the left of that is the actual speed, so it's sitting at 19 or 20. And then the next number after that is my PID output, so it's 10. So the three numbers on the far right are the right motor, and then the next three are the left motor. So I'm basically running sort of okay in a PID. I've got to check it. It's just idling in the air, so I've got to get it on the ground and do some plotting to make sure everything is good with my PID. But the big problem I'm having is if I stop that and I start this and I do something stupid. So I've got three values here. I'm just getting the PID values from the PID function, the library. So it's simple, just call it write PID is the name of my right motor and get KP. So it's just going to bring back the proportional. And the other one is get KI, the integral, get KD, the derivative. And just store them into a number. I don't do anything with this number. I declare it, and just right now it's just being used here. So previously, I was doing that for troubleshooting. So I cleared these guys, and I'm still running. So now if I turn around and get rid of these guys, and compile this and get it downloaded, which is stupid because these tags these variables aren't used anywhere.
Okay.
It's just reading from the PID library. So I don't do anything with them, and it's not the only thing. There's other weird things, like I could disable some of the digital writes, which aren't used. They're just pins I was using for troubleshooting.
Yeah.
And I get the same problem all over the place. So if I start my program up again, so now you can see that on my right motor, I have a set point of 20. I've got an input of 0 because the wheel isn't spinning. And I've got an output of 0. And then on my left motor, I've got a set point of 20. I've got an actual speed of 20 or 19. And I've got an output of 8. So for some reason, it won't run the PID. So something is going on. And it gets even stranger that.
So the first one is the right motor, and the second one's the left motor.
The far three numbers on the right were the right motor, and it was stopped. It was at 0, 0. So
Okay.
20,
So,
0, 0.
Yeah. So it's obviously not being, computed or something because you've got 0 input.
Yeah. So I did some. I'm still sharing. I did some.
All you did was what did you just?
I just canceled. I think it was the right ones. I canceled the right. So if
and the right one stopped working.
Yeah.
So what happened? So I think what that's saying is, I guess the question I have, you're saying you're not using these?
I'm not using these. So if I,
but your PID loops are called R and left R underscore PID and L underscore PID.
L underscore PID is my PID loops. So I describe them.
Yeah, but I mean, does the library, when you're essentially setting them there, are you know what I'm saying? You say you're calling them, but are you calling them or are you setting them there?
Well, no, that's a call. That's get the value.
Yeah, but okay, here you have
here I create the PID.
right.
Left PID is equal to this. Right PID is equal to this.
Right.
Okay, these two. Jump all the way down into my settings. So my setup, and the setup is where I set all my values, left and right.
Mm-hmm.
So I set my left min and max. I set my right min and max.
Mm-hmm.
I set my loop interval left and right.
Yeah.
I set both into automatic, which should start my PID.
Right. Where are you declaring? Where are you declaring your?
So here's where I call my PID to compute it. So call the left PID to compute, and it returns me back a Boolean. Just did it work or not? Essentially, is it working or not? So if I look at these guys, and even when I was getting the zeros out, if I did the left and the right, I was receiving a value that it computed it. So then I said, okay, well, is it really working? So that's where I did the LPID auto, which will turn to bit only when it actually does the PID based on the loop interval.
Yeah.
So, and what I did there is, sorry, right here. So if it's in auto, I just set the pin D2. It'll turn the pin on. And I think I got rid of the, I had a display up earlier and on, what do you call it? Sally, digital plotter there.
Okay.
For one of these.
Oh yeah. I'm with you.
So I just did that to say, okay, am I really calling and running the plot? And this definitely was coming up. I see a spike every 40 milliseconds.
Right. Okay.
50 milliseconds, 49 point something milliseconds. I would see a spike.
Mm-hmm.
So then I said, well,
scope loop.
is it actually, sorry, in auto it went high. So it actually comes back as saying it's in auto, sorry.
Yeah.
Is the PID time ready? So am I actually computing the PID? I set digital output 3 and digital output 7. And I could see a spike at 50 milliseconds for those, 49.8 or whatever it was.
Yeah.
So I do see that it thinks it's calculating even when I was getting 0 coming out of the PID.
Yeah. So that's why I'm saying is it sounds like you've got your P, I, and D all set to 0 somewhere.
Yeah, and so that's why I did the get PID when that was happening. And I was outputting the value, and I was seeing a value.
Uh-huh. But when you what is the line that you cross out again?
That I crossed out?
Yeah.
It's just I commented out these guys, that's the left, and the right. And like I say, if I look at these guys right now, it's used in 2 spots. First spot is where I declare it.
Okay.
Next spot is just where it's red.
Go back up to where you declare it.
Hey Ted, do you think this could be like a compiler optimization thing where if a variable is not used, it just sets to 0 and you needed to make it static or something like that? Kind of seems like that.
No, but this was happening long before I even added these into the mix. So it's been going on and it's been a nightmare to troubleshoot.
Okay.
Because
Well, on that note, and volatile, I think is the keyword you're looking for, Ray. If anything gets modified in the background, whether it's an interrupt or something, you do need to make it volatile because the compiler won't know about it.
Okay.
yeah, so this, as you say, this has been driving me nuts. This is why right now it's one big long program, because I thought maybe I had it broken up into.
Oh yeah, you pulled it all into one. Yeah.
So I had it broken up into different sections, and I pulled it all into one to say, okay, maybe it's something to do with this. And so I put it all into one big long routine.
Could the get call have a side effect or something?
Well, it shouldn't. And if you look at the get call,
I know you can dynamically set the PID parameters. So what's that? How does that done?
Doug, I think you pass in pointers to the variable.
Yeah, I know.
Yeah.
That's what I'm thinking. I was wondering if he is essentially So
Yeah, that's just returning the value, though.
Mhm.
Oh,
Yeah, that's it. That's all it's doing is returning that value.
hey, Pat, that returns a double. You declared those as integers.
Okay.
That shouldn't break anything, but it's not
No,
going to have the correct value.
Yeah, for some reason I thought it was.
well, what is this? Is an Arduino, right?
Yeah.
This
So
is
it-
an Arduino R4.
So I want to say that okay, I don't know what R4 is. I don't know what on the other one a double is a 32-bit.
Yeah, I think.
A double is 64-bit.
Okay, well.
Oh, yeah, that'll corrupt your stack or something,
So
possibly.
Yeah.
Good eye. I didn't catch that.
Oh, I hate doing those. Casting everything the right way. It's always. And it's like you say, Pat. It's one of those things you can't really find it because the code's not wrong. It's just not cast right. Yeah.
I've been fighting this bug, and it's been stupid, dumb things. Like you take code that works, and you comment something out, or you comment add a feature, close the servo clamp, which just calls it. Hey, move this value to the pulse width modulation.
You should have gotten some compiler warnings about that. I mean, if you're using the wrong types.
Yeah.
Yeah, and it's not, which makes me believe that possibly the Arduino R4 isn't quite ready for mainstream. So here we go. So now I'm running, and I'm getting 0 out on everything. And
Okay, so uncover one of them. This time uncover the left one. I mean, well, whatever you did before.
so I believe I had. Where am I? Wait. It's been driving me nuts because it's stuff that should be irrelevant.
Yeah.
And so I had the left commented out before. Right now I got all of them commented back in.
Okay. Now let's see if the left motor's.
If it was me, I'd just put some debug statements in and see if those variables are changing or being what they're supposed to be.
That's a good idea, Doug.
Yeah, so I'm not quite ready to do that because my serial port is communicating to my Python, which is controlling this.
It's not something silly like you run out of memory. I've done that on the Thanos before.
No. So now they're both working again.
So if one of them is uncovered, doesn't matter which. Wait a minute. Well, on this one, they both worked. Last time you had one uncovered. Only one of them worked.
Yeah. So
Ship it. Ship it.
That's right. Leave one of them covered and move on. No.
Square root of
I
2.
had this guy here, for example, these aren't doing anything except resetting the values on communication failure. If I try that, because I know it's given me problems. And these get reset at in my speed calculations, and right before my PID, I create a new set point. So even if I wipe them to 0 before I call my PID, I'm going to set the values. So see if it works. And there it goes. It won't. And so then we do something stupid like, okay, so we uncommented both, and where we were moving 0 in on shutdown, and this is only called if there's a fault right now. So
Yeah.
if I have a watchdog timer failure or my battery goes low voltage, call this. And I set my status to -1 if this happens. So
Well-
right here, set my status to -1. So if I put that back, it's just been, this R4 has been driving me nuts. If I think the next one is just going to get a regular motor driver that I can select the pins I'm going to use.
Mhm.
Yeah, it's kind of looking like somewhere your memory or your stack's getting corrupted.
Yeah, and you'd think it would give me an error somewhere.
Yeah, because that's usually when you're changing where things are in memory and you get different outputs. That's usually because something's corrupted.
Yeah,
And that's working.
and now it's working.
Yeah.
So this
Do it
is
that way.
where-
Do it that way, Pat.
Yeah, but the problem is as I add a little more code, it stops working again.
Yeah.
Ooh.
Ooh, that's even worse.
That's what's driving me nuts.
That is no good.
Maybe the stack's not big enough. I've had that problem.
Well,
Yeah.
if you look here, well, I just shut my share off, but give you an
One thing-
idea.
One thing that I was thinking about is you said you add code and it corrupts things.
Oh, I add little things like,
Adding code pushes where the variables are stored. You might be hitting against that corruption thing that Ted was talking about.
yeah, so if you look at my memory usage, I could understand if I was out of memory.
It's not so much being out of memory, it's where the memory is stored. If,
Yeah, well, the compiler takes care of that.
if your pointer is off the end of your program is where the variables are stored, you add a little bits to the program, that pushes things back. I don't know, it could be. I'm just guessing here.
And the,
Yeah,
and the
but-
stack is really too small. So
Yeah, but you've got plenty of memory.
Yeah, I could understand if I was pushing up against a stack size or something where it's saying, "Hey, okay, I'm out of memory, and I'll just stop." So
I don't
the
think
only other thing
you're
I
just
can think of,
being used by two things.
Could it be an issue with pointers? Your pointers are going beyond the bounds or something?
well, the only other thing is the interrupts, which are pretty straightforward. Basically, if I get an interrupt on a pin, check the other pin and add or subtract from the encoder count. It's a very, very short interrupt routine. And I do that for all 4 pins on my encoders. The 2 pins left, 2 pins right. It's identical routine.
Are those encoder counts volatile?
Yep.
Okay.
That's the only thing that should be worried about being volatile, because they'll change in the background with.
Well, there is one thing. What are the size of those?
These guys are int 32s, my encoders.
Okay, what is the basic on the R4? What is the basic integer size?
It's a 32-bit because it's a 32-bit platform.
Yeah, it's a 32-bit processor, so.
So okay, so it moves 32 bits in a single instruction.
Yeah.
Okay.
So now I was trying to reduce the PIDs to use floats instead, which a float would be 4 bytes. And I can't use it because I'd have to rewrite the routine.
Yeah.
Because in the routine it's using doubles everywhere.
Yeah.
And so there's my other question is, it was written for doubles originally for the Arduino Uno, R2, R3. They're saying it works with the R4, but those are way bigger. They're double the size of the float.
Mm-hmm.
On the Arduino Uno, the double and the float are the same size.
Compiler should take care of that.
I would think.
And you are passing in pointers to doubles, correct?
I am passing in pointers to doubles right here on my PIDs.
Okay,
So
yeah.
I'm sending a pointer. That's the way they want you to call it. I get an error if I don't.
Yeah. And those are doubles, correct?
These are all doubles.
Okay.
So double, 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 not a double. So yeah, just it's driving me nuts.
I just,
Like I'm at the point where I'm thinking about ripping out the motor driver, just putting a regular Arduino Uno back in, and just be able to pick pin 9 and 10 instead of 10 and 11 like this driver board uses. Because I had the old code; it was working really well on the Arduino Uno.
So Pat, this board that you're talking about is it like a board that goes on top of the
Yeah.
it's a cat, what do they call them, a shield?
Cat.
It's yeah. So there's the motor driver board. It sits on top of the Arduino.
Mm-hmm. Mm-hmm.
So
Yeah.
Are you able to do some single step debugging here, set breakpoints?
no. I could. I'd have to buy a JTAG debugger and set it up and do it. So the board is set up for the JTAG debugger, but I don't have one, and I don't know if I really want to go that far deep into it where it should be working. And maybe
Should be working, but it isn't.
it isn't.
When a program is doing something impossible, it's usually because it has a logic error or some kind of typo in the code that you keep looking past. Like one of the ones I always do in C is not put the 2 equal signs in. When I mean equal, I put the 1 equal sign in.
I've gone through that because I've done that before.
Okay.
Yeah, I've done that. So like all my if statements are, looking at exactly that sort of thing. If I'm supposed to be doing something or another. So even to the point where where I've got all of this. Well, it used to be in a compute PID block. And so I just jump up and go into compute PID and calculate out a bunch of stuff. And I kept stripping it back and stripping it back and stripping it back. And then finally I just determined it's okay, I'm down to so few statements, I'm just going to put them in here. And it makes it easy to follow and try to say, okay, what the heck is going wrong? And it seems to be, it's all of my troubles seem to be around the compute PID. So if I ignore the compute PID and I just move a value to my move motors, both motors spin, both encoders count. My speed routine calculates a value for the motor speed. Everything is erroring around this stupid PID.
And it's some library you're using, right?
It's PID underscore v1.h. It's in the Arduino library.
Mm-hmm. That's a good library. I've used it too.
Hey,
Yeah,
Pat, how about we look at the compute PID function and see if there's anything there.
Something awry.
So there's the compute PID function.
It's not doing a lot.
No. So is the Arduino greater than 100? Okay, maybe it wasn't, and I wasn't running this thing, and it was just crapping out. But yes,
No, that's
Wait.
not the compute function.
Yeah, that's
That
not
would
the
be-
function.
but that's going to start, am I including the old logic versus the Arduino logic, the old Arduino code?
There it is.
Yeah, so PID double where you declare it. So that's supposed to be where you declare it with the int p on. And here, that if you're declaring it without the int p on, it just puts the p on e by default into there. So basically jumps you back up to here, calling it.
Yeah, but let's look at that compute function.
So the PID compute right here. It's not very
Yeah.
long.
Okay.
Are you paying attention to the true and false return value? Are you using that correctly?
The true and false. I've looked at the true and false values coming back, and they are in fact working properly. So when it's executing, it's telling me that it is true.
And it is using those references that you pass in, the pointers to input and set point, it looks like.
Yeah, it converts them over to my input, my set point.
Yeah. So yeah, it should be using what you have in your code.
Yeah. So that's where the debugger comes in, right? You would step through this and maybe you just immediately spot what's happening. Something, you know, it's if it's producing no output, like everything's, you know, you said something about zeros, right? I mean, that suggests it doesn't have the right input.
Yeah. So here where it's set, you know, it's supposed to be setting, it's supposed to be setting the output. So here, I don't know if it's trying to execute this guy and it's saying, oh, your output's 0.
Oh, okay. So you were saying your output's always 0, right?
Yeah. So it's something stupid that I set, and then all of a sudden my output becomes 0. Otherwise, my output becomes output.
Yeah, so make sure that P on E isn't true somewhere or isn't false.
P on E is specified.
Because if P on E is false, you'll get output 0. Oh, but then it adds in the output down below.
Yeah. So either way, it should never be 0.
Yeah. Here it's giving you
Unless the out, min, and max are somehow.
Yeah.
Time to get out the debugger.
That'll be, I think, the next investment if I'm going to continue using this board, because
No, but the board, does the board have like, it probably doesn't have JTAG pins, it probably has like SWD pins exposed. It's like less number of pins, right? Something.
What is it, 4 pins or something?
So JTAG is usually 5 pins, SWD is like maybe as little as 3 pins, but one of those you probably have. Most of these newer boards give you access to the debug pins. So it's a genuine Arduino Uno R4 Minima. That's what it's called.
it's a genuine, yeah.
Yeah, isn't it based on an M4 core?
It's based on a Cortex M4 core
Yeah.
with a floating point unit, which would explain being able to use double. Just wanted to see that.
Okay, I found a page on the Arduino website. Yeah, they have SWD pins exposed, like I thought. It's like, just search for SWD.
Hey guys, the hardware does not support doubles. It only supports singles.
Really?
Yeah, the compiler will convert everything to float. I think.
Well, I'm saying that the older Arduino would convert doubles to floats. Whether the new one does or not, I mean, whether for that particular processor. But I'm just saying, I would be very leery of declaring doubles as opposed to floats.
Where are you seeing that, David?
I'm not seeing that per se, but you were talking about using doubles.
Yes.
And I'm saying I would avoid using doubles. I would use only floats.
Yeah, I can't with the library. It's expecting doubles unless I rewrite the library.
Okay. All right. Well, like I said, I know that the ARM chips, unless it's I don't know, the 7s, all the Arduinos are not Arduino. All the ARM chips support floats, but not doubles.
Okay.
Yeah, I'm pretty sure behind the scenes what the GNU compiler is doing, it's being told by Arduino, by the platform IO, hey, just treat all doubles as floats. You can Google that to confirm. I think it's definitely a yellow flag, but
on the Arduino R3, a double and a float is the same size. They're both 4 bytes.
yeah, and it's probably the same here because behind the scenes,
I'm saying the 4, you're using 4, right?
On the Arduino 4, there's 8 bytes in a float, or in a double. It's 64 bits.
Okay.
So I did that with there's a routine print size of. So I just looked up the size of, an int32, a float and a double. A float was 4 bytes, a double was 8 bytes.
God, that doesn't seem like enough bytes for a float. It seems lovely.
Arduino does it with
the
4.
standard float is 4, double is 8. That's correct. I'm surprised they're doing true doubles. I thought they would, behind the scenes, just treat everything as float.
That's the right number of bytes. I'm just saying that. I don't know.
Yeah, it's just, I'm at the point where, this thing needs to be rolling on the ground. And for a May contest, I think it's cheaper.
Yeah, it's got the pins, and what processor is it? Is it an ST Micro or something else?
It's the Arduino Uno R4 microcontroller.
Yeah, but now what's the
That's
CPU?
the board, yeah. The processor.
CPU on the Arduino board,
Yeah.
the Cortex M4.
Yeah, but who makes it? From who?
Oh, Renesas?
Oh, okay, Renaissance. Okay,
Renaissance,
okay.
yeah. Old name for
but
Hitachi.
It's asking because a lot of people have like those dirt cheap SWD gadgets that you use with your blue pill and black pill and green pill, like ST Micro kind of boards. Those are the dirt cheap JTAG/SWD interfaces. I don't know if Renaissance, if that works with the Renaissance micros or not.
I believe it does, but I have to confirm and what JTAG I would need. But like I say, I think I'm going to make room for a separate board and just.
Boards only support single precision in hardware. It can do, maybe in software, it can do doubles, but the hardware supports singles, not doubles.
So the Cortex M4 only supports single, but then that's probably something the compiler is doing in Arduino to convert that.
Yeah, probably software floating point.
It can do that in software or.
It's got a floating point unit in it, so David.
It's got a floating point in it, but the floating point only supports singles. That's a characteristic of that particular kind of ARM chip.
Okay.
Yes, I was wondering if this dirt cheap ST Link device, you can get this for like $5-10.
Yeah. I have one.
With the Renaissance chip.
I don't know.
You might already have one of these, right? You have one of these?
I have one.
So the thing that you use to program it is the same as what you use to debug it? Right?
Well, these guys on the blue pill, right? You program and debug with this like on something like a blue pill.
Okay.
Yeah. The problem I have is that the pinout is 1 millimeter spacing pins, and I'd have to get a connector to fit into that. Like I say, the more I'm looking at this, and I figure, okay, you guys would point this out right away.
Well,
There's way more brains on that side of the screen than this side of the screen.
Well, you got a solution. If you comment those few lines of code out, it seems to work. So, you know.
As soon as I want to add the next thing in, I'm done.
Okay, so why don't
There you go.
set up a bug bounty? You know, what's the bounty? You know, we all go offline. You post
There you
the code,
go, yeah.
get up. We all go looking for bugs, and you know who finds the most. You know.
Yeah, post your code.
Post my bug bounty. Find my code problem.
Did you ask ChatGPT?
No, I didn't. I did not
That's
ask
too easy.
GPT. What's the problem with my code? It'll tell me David's answer.
Fix my
You can't
code.
use doubles on a Cortex M4. So that's it for me. That's been my headache. I've been working way too hard to get motors to spin.
Tom's sitting back going,
And it's all because I've got the frequency down to, I think it's about 50 hertz for the motors, and they're working well. Like I can spin them fairly slowly there, 20 centimeters per second.
Yeah.
Which, it's not working too bad. On the Arduino, because of the pinout on this stupid driver board, pin 10 and pin 11, as opposed to pin 9 and pin 10, I need the timer on two separate, to change the timer value on two separate timers. To change my pulse width modulation frequency, and I can't get them the exact same.
Does the driver board use pin 9?
No, pin 9 is totally available. So I'd have to hack the board and try to move it over to pin 9.
Mm-hmm. That might be doable.
Yeah, I already hacked it and took pin 5 that was being used for something. Pin 13 was being used. So I cut the trace and I moved it over to pin 5. So I'd have to find, like you say, get pin 10, cut the trace and move it over to pin, or pin 11, cut the trace, move it over to pin 9 or something.
Yeah.
That might be the path of least resistance.
And maybe for this robot, because I'm this far into it, because it's ridiculous. But then I still have the same problem with, pin 9 is my servo driver.
Wait a minute. On this board?
On the motor driver board, it has a servo pin output. And it uses pin 9, D9 for the servo.
Sounds like something that could use pin 11.
Yeah, so I think that we would turn around and just, by the time I jump around all the pins on the board, just go spend another $10 on Amazon and buy a different driver board that I can put the pins where I want them.
Yeah. The reason you went with a cap was or a shield. I think on an Arduino it's called a shield.
It's a shield, yeah. They were cheap at the time. When I first bought them, they were $10 or $15 and it plugged on.
Okay.
Why somebody would design one like that, I don't know.
Yeah. Well. Yeah. That's a solution. But I was looking at your robot and it looked a little fat in the belly. You're getting close to dragging right on the bottom side.
Oh no! Come on, we're on a floor, and I have.
No, but I mean, but I'm just saying is that if you took that cap off, shield off, and used a different driver, would that cause you any problems?
Oh yes, but I'll have to find another spot for it.
Yeah. Let's see the robot again, just for curiosity.
We didn't
solve your problem.
Okay, so there's a robot.
Okay.
Got the servo. In the middle, I've got a time of flight sensor to spot the can.
Yeah.
2 wheels. Raspberry Pi 3B,
Mm-hmm.
Arduino Uno motor driver, 2 yellow TT motors with the encoders on the
Yeah.
Back end.
Yeah.
the encoders on the back end of the motors.
And
And then, okay, what's that module over on the side? Is that a power translator?
At that power, yeah, I'm going from 11 volts to 5.
Okay,
DC to
got it.
DC converter.
Yeah.
So
Oh,
DC.
it's a nice looking little robot. What's the Pi used for again?
what do you
What are you using the Pi for?
Secret weapon.
Oh, the secret weapon. Okay.
All right.
All right.
Is that why?
Is that why you have a,
Is that why you
is that
have?
why you have a big
Originally, it was
hole in
gonna
the
be
top?
for translating sensors and cameras.
Okay.
Okay, cool.
That's why there's space on the top that I can't put another board up there.
Mm-hmm. Mm-hmm.
I can't give away all my secrets.
Okay.
Okay. Well, right now Tom's kind of going, wow.
Exactly, but I'm thinking about the motor drivers. I have room right here on the side.
Mm-hmm.
Okay, so I've got a little bit of room right here or right here.
Yeah.
So maybe I could put something there.
Because those things only, I mean, if you have a 1 amp motor driver, they work fine on that, on those TT motors.
Yeah, I
I mean,
forget what they draw. I think they got a stall current of just over an amp.
That's what I'm saying. They're not in normal use. They're like a couple hundred milliamps, maybe.
Yeah, so when I buy drivers for them, I try to find a driver that's 2 amps continuous.
Thank you.
Doug, didn't you post or show us some motor drivers that you picked up for cheap that can do that?
Oh yeah, yeah. There were several.
I've ordered a couple.
Yeah, yeah.
So that's my backup plan. Is I think I'm gonna end up using one of those.
Mm-hmm. On the M4, is that a does it take a 5-volt input? Is it totally all pins are 5-volt, right? And that's supposed to be
all pins are 5-volt compatible.
Yeah, that's what I thought.
So they'll output 5 volts as well as input 5 volts.
Right.
So that was the other attraction with the R4.
Mm-hmm.
Aside from the memory leak or whatever it is causing my problem.
Yeah. Well, if somebody mentioned posting the code, if you could extract just what the minimal problem is, just a loop or something, some little snippet, you could, people might be wanting to work with it as a puzzle,
That's where
I'd be happy to look at it.
Huh? I'm sorry, Ted.
I'd be happy to look at it, Pat. I'm not in the contest, so.
Yeah.
Oh, it's just a motor driver. There's nothing secret about that.
No, I meant the PID loop code. I don't know what you got. Yeah. Why don't you send Ted?
I can send you a copy. I'll zip the folder. It's in Platform IO.
Perfect.
And you can just pull it in and do that.
Mm-hmm. Cool.
Will do.
Will do.
Okay, I think I've got your email, Ted. So.
Yeah, you used to anyway.
Yeah. I usually don't erase these things, so.
Mm-hmm.
That's it for me. I've taken up enough time tonight, guys.
Well, interesting problem. Okay.
A motor driver. I should be able to tune a PID loop and a motor driver in a day. And I've been at this for weeks.
Yeah. Wow. Yeah, you should have called for help earlier. I didn't
want to look stupid.
What they say is, if you can't tune a motor driver, tune a fish.
Exactly.
I cannot believe it took you folks that long to get the tuna fish out. Come on. I've been sitting over like, come on, tuna fish.
What I can say is Murray was correct. All problems are with PID loops.
Yep.
Yeah. Okay. Well, anybody else have anything else to do, or do we go to freeze talk? How about you, Harold? You joined late, and I think David joined late. You guys got anything you want to show?
I'm driving home and I'm in the car. I'm
Okay.
looking for things, so I got nothing really to chime in except for just witty quips and phrases that don't really have any real good meaning or.
Okay.
Yeah.
Well, Kareem, how is Iron Rain doing right now? What do they got? Anything new? I don't know if he might not be there in real time. Okay. Let's see, what time is it? It's 9. Is this going to be the time we quit at 9:15? Or surely you guys got something to talk about?
You want to go back to the PID loop?
Well, have you guys ever heard of something called Ducky Town?
Ducky Town.
Yeah. So basically, it's a lot of universities that got together and designed a simple robot platform that I think is based on Jetsons and a city, a fake city layout. And they have contests for self-driving cars using Jetson and AI and machine learning, various algorithms in this.
That sounds cool, Brad. Where do you have a link for that?
Yeah, let me find it real quick. Yeah, I've got it.
Is it all simulation, or is there an actual?
Well, it's got simulation. You can simulate the Ducky Town, but there's actual real robots as well. Let me post that.
Yeah. How many blocks do you know? Just curiosity.
It's apparently the smallest grid. It's an extensible grid, right? So the smallest grid is like 2 meters by 2 meters, and you can build on that. So the traffic lights and some of the controls are also driven by like Raspberry Pis. So there's some intelligence in the city layout as well. But it looked pretty cool. It's most of the robots are ROS based, and so you can simulate. They've got models apparently that you can simulate, but yeah, it's basically a bunch of universities that got together in Europe and the U.S. I think MIT is one of them. I think Rensselaer Polytech's one of them, and they do these little contests. So I thought it was pretty cool.
Yeah, that is pretty cool.
And they use those TT motors. I mean, there's nothing special about the robot. I mean, it looks to me like there's nothing that a lot of the people in this group already do with their robots, but they do for their competitions or their training or whatever. They do limit you to like a subset of hardware. But I thought it was pretty cool. If you go look at the robots, they're simple TT motors with a Jetson on it, and then they have their own motor driver board that's pretty simple.
Kind of looks like Donkey Car.
Is it based off of RC cars? Not if they're using TT motors.
Yeah. Well, I did Donkey Car, training, and it wasn't based on TT motors. There were other motors. It was a differential drive robot. It wasn't an RC car.
Oh yeah, I'm seeing pictures of 2-wheel drive cars.
Yeah, doing Donkey Car.
But I mean, the official Donkey Car design is
it's
based on RC car.
Yeah.
It seemed, I don't know, there's just something wrong about having a Jetson or being driven around on TT motors. It's something.
At least go up to a 25 millimeter motor metal.
Yeah.
But the idea is that you can have multiple cars on the track, so you have dynamic objects that have to when you come up to an intersection, they basically have to decide. Those LEDs that you see on the robots are for communication between, different vehicles on the road. And so they negotiate who gets to advance. And so it's kind of a cool concept. And they're using it to teach robotics and AI concepts, machine learning at these schools.
I think the later version of Donkey Kart, you could actually train it to pass a car, but it didn't have intersections that somebody might have to come to a full stop.
Mm-hmm.
So it might be an idea for like a future contest.
Yeah. Probably, some simplification of it if we could figure it out, there
doesn't seem to be anything very special about the track. They're charging an arm and a leg for it, but it doesn't seem like it's something you couldn't do with, colored tape and maybe some design around the traffic lights, depending on how complex those are.
So they're not putting like fake buildings and stuff on it or anything. It's just a track.
Yeah, it looks like it's just a track. The ducks, the rubber ducks, are supposed to represent pedestrians. Mm-hmm. So there's some. I haven't looked into this very much. I just saw a talk on it. Thought it was kind of a cool concept. Mm-hmm. That people were using it to, for training. But the pedestrians, there's some kind of penalty, I guess, for running over pedestrians.
Mm-hmm.
So I guess you can chuck a duck and see if your car avoids it or something.
Yeah. Pretty cool concept, and it seems to have a lot of support. I think there's some courses on it. It's similar to a JetBot from NVIDIA as far as the car design goes. So there seems to be a lot of simulator support and library support if somebody were interested in doing that.
So,
and they are going to drones, to quadcopters at some point for a similar kind of setup.
Well, that's neat. I had never heard of that one. So that's really good, Brad. All right. Let's see. Anybody else have anything? Hey, Doug, you said you'd done some modifications to your dog, and you said you beefed up some stuff. What did you beef up?
Well, you see the screw here? If I'm pointing at it.
Wait a minute.
My hand on it.
Give me a second. Okay, yeah, I do see that screw.
Okay, so that's supposed to stop this thing from going too far. And it works just fine on this side, but on the other side it doesn't. So now I'm going to have to move it down below the dog so that it works better on the other side too. I got to buy more hardware. So it's made a little progress today, but not too much.
Okay.
Based on this screw right here, which is a 3-inch screw that basically is just supposed to stop that leg from moving forward too much, because the system I used before, it jiggled out and the legs would collapse while I was driving. Very embarrassing.
Yeah.
Need something a little sturdier to go across bumpy roads.
Right.
And that's about all I've been doing lately.
Motor driver still hanging in there?
Oh, yeah, motors are spinning. Everything's working good. I didn't get my version of the PI XXX lube going.
Okay.
Basically, I was using the encoders to speed up or slow down one side of the motors, and I haven't finished that code yet. But I tried using voice control stuff, but I think my download of the libraries was wrong, so I kind of tabled that while I was working on the hardware. So a whole bunch of little things that haven't quite got done while I've been traveling too much.
Yeah.
I'm not going to travel for a while, so maybe I can make some progress. Although I'm out this weekend working on the astronomy site. We're laying a cable for the electricity.
Yeah. So are you guys going to celebrate the solar eclipse thing? Any way special?
I heard that they were doing a members only thing down in Grandview, which wouldn't do y'all any good. I'm going to do it in my backyard because I don't have to carry my equipment as far.
Mm-hmm. Yeah.
I thought we were in a good viewing area this time,
We
like
are.
even in Dallas, and
Yeah. We get
Yeah.
to see the total eclipse, I think, for about 4 minutes. Some places get to see it 5 or 6. 4 minutes is plenty of time for me.
yeah.
We're not exactly in the middle, so we don't get exactly the longest time, but we're still in a good spot.
I heard someone say, no matter how long the eclipse is, it lasts about 8 seconds.
That's not true. It's really long, and you'll find out in April. We've got multiple minutes.
I know, but it feels like 8 seconds.
Yeah, that could be.
Mm-hmm. All right. Well,
Yeah, I don't know if you can see it. That's the, oh, it's going to flip. Oh, cut it out. That's the output of my solar array during the eclipse, the dip there.
Yeah.
Yeah.
So.
Yeah, you guys are lucky you got it in your backyard.
Oh, yeah. I forget you're not here. We're only lucky this time. We've been unlucky on other times. The last total eclipse was in Missouri. I had to drive to. Of course, it hit other places too. That was just the place we drove to.
I thought the other one came through. It was in Colorado, wasn't it? There was like a.
It probably went across between Colorado. It goes across the whole country.
Yeah.
Or,
Yeah, the one
swaths across the planet.
In 2017, it was north of us through Wyoming and Nebraska.
Oh, was it? Okay.
And then went across to Missouri and kept going. We just picked Missouri for some reason. I wasn't the one that picked. That was where my Miata group, we all drove our cars out there. So the fun was the going, and we got to see an eclipse.
Well, I guess one question I have, now that we kind of see where Pat's going on his 6-can robot, I think. Tom, how are you doing on your 6-can robot?
Well, since you asked, I'll share my screen here and let's get some wires out of the way. I've been tinkering with it as we talk. I put power on this thing yesterday. The cable, let me unplug it. I put power on this thing yesterday. You can see the lovely little stand I built so I can run the motors without having it take off. I have a nice digital tack, and that's why there's that beautiful symbol stuck on the wheel. Many of the things I've got in here I've tested as unit tests, and they're all working fine. I'm now at the point where I'm attempting to get reasonably useful speed feedback from those little tiny 20-hole encoders that come with TT motor sets, which is what this thing's got. Do you
have the DF robot motors, or are you talking about this little slot thing they put on the opposite
side? A little slot thing.
Oh, okay.
Yeah. So I have some work to do to get to the point where I can get stable speed measurements, and then I'll have a speed regulator, but it will be a slow responding speed regulator, I think, based on the math I've done.
Okay.
Right now the encoder feedback, I'm using logic I built for a much faster encoder, and that logic is unstable when combined with the PID loop.
Okay. Now I'm going to say right here. Let me look at. Can you hold it off the stand so we can see the motors, just to make sure there's nothing weird with them?
It's screwed onto the stand, so I can't really pull it off.
Okay. All right. Okay. Oh, I see.
If you look under there, you can see where all the
right.
are.
So you're talking about encoders on the wheel shaft, not on the back of the motor, right?
Right. Yes, that's the bad side. That's the bad.
Yeah. I'm going to tell you right now. Save yourself a lot of time. Save yourself a lot of effort. Go to Mauser, buy 2 of those motors at $7.50 a piece, and you will be so much happier, and it will work so much better.
They'll not only be faster, but they'll be 2-phase encoders. This is just 1 phase.
Right. So I'm just telling you,
the logic is a real nuisance.
Yeah, I'm going to say this is not the way to go, Tom. I've been there. I taught a class on this one, and I want to tell you, you don't want to go there. But okay, I will say one thing you have to be really careful with. If you're having a lot of instability that you didn't expect, those optical coupler boards. They often have a lot of false pulses, and you can get rid of it by putting a signal to ground, a very small, like a 0.1 microfarad capacitor. Okay. And that will, so, but if, do you have access to an oscilloscope?
Yes, I do.
Okay. Take a look at those the output on that. And I think you'll see, because I ran into that and had to fix that. And then later on, I read about somebody else who had the same problem and how they fixed it, which was the same way. So, if you dead set on using those, make sure you're not ringing, because that will give you some weird results.
That's a good point. I'll put it on my scope and have a look at it.
Yeah, and then I'm going to say, then crank out your and pay $20, get two of the new motors and put them in. They fit. There's nothing unusual about them. They work right, and you'll be happy.
That would
So
be
those come with encoders on the back of the motor?
No, those the DF robot motors do.
Oh, they do. Okay. Wow,
Yeah,
that's
but not the classic TT motor.
right.
That one has an extra shaft. The drive shaft extends on both ways.
Yeah.
And so
It's just a slotted disc.
yeah, slotted disc. And for the speeds you're normally running and the time loops that you normally have, you're fighting like, oh, well, do I have 3 or 4 pulses this time? You know, it's really bad.
Yeah. I've done digital filtering on my previous implementation with single phase encoders, but it was still much faster.
Mm-hmm. The dual phase really helps, but because it gives you direction. But you can, if you have enough resolution, you know, what I like to call them a tachometer type, they'll work fine.
Yes.
But I don't think I think you'll find that they don't have enough slots and they don't spin fast enough to give you a whole lot of control. You can do stuff with them. And there's another option where you can look at, instead of counting the pulses, you can look at the width of the pulse. And that type of logic's a little more complicated because it breaks down when you're not moving.
Yeah. Doug, the logic that I'm using computes the speed both ways.
Yeah.
Pulses per unit time and the time of the pulse width. And it switches between them and it filters them both.
Okay, that's good. That sounds like a nice program.
Approach.
Mm-hmm.
There's somebody who does a really good analysis of both approaches. Her website is called curiores.com.
Can you put a link in?
Yeah, I've got it right here, I think.
Okay.
Just find it. I'll stick the link in. She's very, very good on a number of topics, and I learned a lot from her approach towards providing very practical velocity information as well as position coders. You just see where this thing is here.
On those motors, is there a way to get at the motor shaft rather than the gear down or wheel?
Not really.
Well, you say that, but in my earlier days, before I knew about DF robots option, I actually did create a similar type encoder inside of the motor. It wasn't worth it. Yeah.
There's one of her YouTube articles, and from there you can trace it back to the websites and the GitHub.
Okay, that's great. Thanks.
It's pretty. It's a really, really good presentation.
Yeah, because I want to say a combined approach does sound really interesting.
She provides Arduino code as well on her GitHub for the various things that she discusses in her YouTube videos and on her website.
Do you offhand know her GitHub name? Is it CurioRes, or is it another name?
It's CurioRes.
Okay.
CURIORES. I'm going to see what else I've got sitting here. Here's her website. I'll stick that in too. I implemented this stuff when I was working on my tri-wheel robot, my Tribot, and I found that the approach that she suggests for that particular hardware worked very, very well. I got really good speed regulators using single-phase encoders, but the encoders were mounted partway through the gearbox on each of the 3 gear motors that are in a Tribot. So I got much faster pulse rates.
Yeah. Vex does that on some of their older motor designs. That you would actually buy the motor and then you would buy a special encoder kit. And what it did was it replaced one of the internal gears with a one that had a optical type of a reflective type IR encoder. So it would have a wheel that was black and white, black and white, black and white, and you would bounce it off of that. So, and those worked well too. I mean, that was nice because you just had a couple of screws. The problem with a lot of these TT, some of the TTL motors you can just unscrew, but some of them you have to unglue. And those, by the time you get finished ungluing them, they're broke. Yeah.
Well, I've only ever bought 4 of the TT motors, and I've now used all 4 of them in projects, so I will never buy them again.
Yeah. Well, I'm not. They have their place, but there's so many better solutions.
Yes.
Yeah. Yeah. So.
I've got a little show and tell.
Oh, right. Okay.
Yeah, it's just. So I've been working on the mock-up, which is just basically a board with my parts laid out. My wiring is not nearly as clean as John's last week, but basically it's just so I can play around with the sensors. I kind of did, testing of all the sensors and actuators individually, but now I'm trying to integrate everything in refactor code and all that. So I've got the dual, I don't know if you could see it, control panel, and there's a dual terminal strip there for the, there it is. So the snubber diode for the motors, and Arduino Mega here, and then motor, and then my bump switches are there.
Actually, Brad, this is an interesting idea. I've never done it that way. I've always just kind of like started off with some platform. I think it might be because the fun I have is building a platform.
Yeah. The upside of this is that it's easy to, if something doesn't work like you think it should, it's easy to just yank it and put something else in there.
Yeah.
The downside is it's not rolling. It's not going to move on its own. And so you don't get the joy of actually seeing, something work. But, if you double up on your hardware, you've got a mock-up, you can work on the bench and say, okay, why isn't that working? And then you can correlate that with the robot. So.
Well, that's fine. I said I have never done it that way. That's kind of interesting.
I've done this not for robots, but for other things.
Yeah.
I had to field hardware and needed a test bench set up.
Yeah.
So it works, but there's downsides. Is that
okay.
You've got two different hardware implementations running around possibly, and
Yeah,
it's a pain.
yeah. Or like Pat's problem, if you only got one motor on there, right?
Yeah, I mean, so basically I've drilled out this, you can't see it, but the way the board is laid out, it's exactly the same form factor as the robot is.
Oh,
And
gotcha.
I've got, these are just the side plates for the robot. I've 3D printed some of them.
Yeah.
That's the green one. So I can replace the panels, the side panels that I have mounted on here, which are the actual robot panels with, something like that.
Yeah.
When I actually, go back and rebuild the robot.
Okay.
So the layout's the same. I have another set of holes drilled for the other motor. I can run them both, but I'm not doing it right now. It's just doubling the hardware.
Yeah. Well, that's neat. Yeah, that was a good show and tell.
Well, when something moves, it'll be neat. But right now, it's pretty static, and it flashes LEDs, and that's about it at this point.
Yeah.
So your snubber, is that just an RC, across the switch to
It's
barking?
It's so that I don't get kickback from the motors when they're powered down. So there's an RC on that motor driver.
Yeah.
Some of them don't mind that pulse from
Impulse,
that inductive charge.
Kick. Yeah.
But some of them do.
Yeah.
This one does. So it's basically just a protection for the IC that's on the motor driver. Is all.
Yeah. Basic Micro recommends that. Well, they recommend a diode across the switch.
Yeah, that's a basic motor, basic micro.
It was. Yeah. Okay. Yeah, that's what I thought. Maybe you were using that.
Yeah, it's overkill for something like this, and I was basically going for, I need something that's not going to take a lot of thought or a lot of design work that I can just throw in there and.
Oh yeah, it's great. You can set up the PID constants, automatically, and and do moving profiles and acceleration to a speed to the deacceleration to a position.
Yeah. So if Pat's having trouble with his PID loop, I've got no chance. So I just let the motor controller do it.
Oh no, you're way ahead of the game. I mean, you just throw it a command and it does the timing and everything.
Yeah.
Own little independent loop. That's what I like about it anyway.
The other thing I wanted to bring up is, some of us are better at hardware. Doug likes doing that. Some of us are obviously better at software, and then there's people like me that aren't really good at any of those. But have we thought about creating like a curated set of kits, maybe a controller setup or a cheap robot base, especially for newbies, to get started quick. Where good hardware, maybe it's a set of controller and some basic libraries that do, move the robot up so many feet, back so many feet. Maybe if it's, if you're great at software, maybe it's just a basic, hey, we've tried this kit and it works. I know you were talking about something like that, Doug, a couple of weeks ago.
Yeah, we did a club robot at one point.
Yeah, we've done a club robot twice. And I was saying that this year is probably time. The last one was done in 2016. And it's probably time for something like that again. So the club is going to be doing more in-person stuff like that. And so I would say, Brad, there's probably a good chance that this year that'll happen.
That would be awesome.
But I don't think it's going to happen like, I would say probably it would happen after the May competition.
Makes sense. Yeah. It would be, I know that like SRS did a kit and they had some problems, right? So it wouldn't necessarily have to be like, hey, we're going to build this kit. It would maybe be, hey, these are, a set of kits, at varying dollar costs that various members have tried that, we think work, something like that. And here's the link where you can go pick one up if you want to get started.
Yep.
Well, that would be a cool idea. I'm going to capture that, Brad. But it's kind of an idea of maybe kit review.
Yeah.
Yeah. Let me think about that a little bit. We're trying to do a few things to the website. We're trying to have like a new member orientation and a jargon dictionary and a few other things, and a snippet, possibly a snippet library, but those are just right now, they're just gleams in the eye.
Right. I mean, you've got pieces of it, like you've got the lib DPRG stuff that's out there, for the multitasking, and then there's various libraries that people have kind of settled on, it seems like. But what I was thinking is something like hey, for the tabletop, or 6-can sets of competitions, or four corners or whatever, you have a few kits, and then I think, Ray, you were showing a build-a kit that you bought for outdoor competitions, maybe that, and one or two, not a Traxxas, because that's out of my price range.
Well, I do have one piece of advice for tabletop robots. Don't make them out of Lexon. I mean, not Lexon. Don't make them out of acrylic, because the first time they fall on the floor, all of that's going to shatter. And you might ask, well, how do I know? Well, I actually had a tabletop that started off as 100% acrylic, and after, I think, by the time it competed the second time, it was about 50% hardboard, and all the other, that meant about 50% of the pieces had broken. So anyway, something.
Anyway, give it some thought and see if that's
okay. Well, that's a good thought. I'll put it down.
Yeah, too bad the makerspace doesn't have we could make dies and actually press out an aluminum chassis with bends and everything else. But at least I don't think they do. I don't know.
No, they don't. No, you can mill those things out on a CNC.
That's true.
And if you're good with design and you know how to bend curvatures and stuff, you can actually bend them with, and I think at the meeting I was showing people a small kit that I had built over last week or so, and it was called Pie Dog. But what I mentioned was that the aluminum used in the kit is 1/16 of an inch, or actually probably 1.5 millimeter. But that's fine. It's a fine thickness for most robots our size. You don't need 1/8 and 1/4 inch aluminum plates. You can get by with a lot smaller.
Yeah, I know there's certain alloys of aluminum that will bend, and I think I have the ones that wouldn't. I want to say 6061 is actually kind of stiff and brittle, and if you try to bend it like into a 90, it'll just break.
Well, I don't know. I was going to say 60. There's one that starts in the 7,000s. That is like, God, don't even try it. I mean, it's not going to bend. I thought you could bend 6061.
That's what I thought it was. It may have been a different alloy, but I tried it.
There's another one that's a structural aluminum, which bends easy, but it's not. It has other properties that are not as. It's got more aluminum in it. It's not as nice as, in my opinion, as 6061. And I think it might be too. Ray, are you trying to bend 1/16 inch material, or are you trying to bend 1/8 inch material? You know, there might be a thickness problem there.
Yeah, I think this was somewhere in between. It wasn't quite an 1/8, but it you know, it was thicker than a 16th. So
Yeah.
probably some metric gauge or something.
Yeah. Anyway, that's a thought. I have some work to do with some aluminum plates that I'm going to be doing when I get time. I don't have time now, but when I do, I'll give that a shot and let you know what the results are.
Yeah.
Yeah. Yeah. And the other thing that I don't think we use very often in robot building, which would be interesting, and that is vacuum forming. You know, the obvious thing is some sort of top canopy, but it could also be used for doing a basic
chassis.
Yeah.
Yep.
And I've done some of that at the makerspace with 1/16 inch ABS, and you know, here's a piece of it here. It does pretty damn good, and once you get the bends in it, let me see if I can.
Doug, your image is off.
Yeah, I'm trying to turn it on. There
Oh,
it is. All right, so if you pin me, we'll see what we get here. Okay, so
okay.
See, and this is 1/16 inch material, and once you get this pattern in it, it is very rigid. So, and ABS is a nice material because it's pretty indestructible. Anyway, something to think about. And vacuum presses are fairly easy to build. They're not you know, not too hard, but you know, all you need is some sort of heating element and a way to slide, and a way to hold your plate in a nice position and slide it down over the vacuum table. And a vacuum table can be as simple as pegboard, you know.
Shop vac.
Yeah. And pegboard and a shop vac. So they're not crude ones. I mean, if you look on the web, there's 1,000 designs that you can make for those guys.
Or you could find somebody who's a DSS or DMS member and say, "Here, stick this on the plate."
Yeah, well, that's possible. That could happen too. But
Yeah.
I haven't been down there enough to know what the status of the vacuum former. They had a gorgeous vacuum former. That's what's one of the things about the makerspace that happens. They get a really beautiful piece of equipment, and nobody really takes ownership, so it never really gets put into full use. It's not utilized very well, or it gets utilized by 2 people, you know, that sort of thing.
Yeah.
And because like all the equipment down there, you have to be trained on it. And it's not much training. I mean, it's like, don't stick your hand underneath it when you pull it.
Yeah, that's right.
Stuff like that. But anyway, yeah. Okay, well, I think we've reached the point, guys. I'm going to, Chris has already left the meeting, and I'm saying, let's cut it off and leave. All right, bye, guys. Till next week.
Next week.
Yeah.